Today we are going to learn operation of sets. First operation is intersection of two sets. Suppose A and B are two sets, two different sets. The set of all common elements of set A and set B is called the intersection of set A and set B. It is denoted as A intersection B. Intersection symbol is this, inverted U. A intersection B, and we read it as A intersection B. So what is A intersection B or intersection of two sets? That is the set of all common elements of set A and set B. The common elements of two sets are called as intersection of two sets. You will better understand by the example. Example 1. Suppose if I take set A equal to as set B equal to as up to 20. Now, what are the common elements between set A and B? So that will be A intersection B. So A intersection B is the common elements of set A and set B. That is 10 is here because 1 to 50 is set A. So 10, 11, 12, 13, 14, 15. This is A intersection B. So we can also explain A intersection B as X is an element such that X belongs to A and X also belongs to B. In this way we can explain intersection of set A and B by the builder method. Set builder method. So this is A intersection B. Another example, if I take example 2. Suppose I take, before going to the example 2, let us draw the Venn diagram. Venn diagram of this, that is set A, this is set A, this is set B. A, this is B. Now, what are the common elements? That is A intersection B, 10, 11, 12, 13, 14, 15. So 10, 11, 12, 13, 14, 15. These common elements will come under this intersection part. A, 10, 11, 12, 13, 14, 15. These are the common elements, that is A intersection B. And this set A is containing elements 1 to 15. 10 to 15 is here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, 11, 12. So set A is containing 1 to 50. Now set B has the elements 10 to 20. 10 to 15 is here already. 16, 17, 18, 19, 20. So this is the Venn diagram for A intersection B. Now this intersected part, this part is A intersection B. This part is A intersection B. This is the Venn diagram for intersection of two sets. Now, example 2. If I take set P is equal to as 21, 22, 23 up to 35 suppose, then set Q is equal to as up to 40, set R is equal to as 32, 33 up to suppose 45. These are three sets. Now we can find intersection of P intersection Q, Q intersection R, and intersection between all three, that is P intersection Q intersection R. So P intersection Q. P and Q, set P and Q, you see the common elements. Q is having the elements as 21 to 35. P is containing the elements as 21 to 35. Q is containing the elements as 27 to 40. So, common elements 27, 28, 29, 30, 31, 32, 33, 34, 35. These are the common elements of P intersection Q. Then Q intersection R. Let us see Q intersection R. That is 30 Q and R. Q is containing the elements as from 27 to 40. And R is containing the elements from 32 to 45. So 32 is common, 33, 34, 35, 36, 37, 38, 39, 40. This is Q intersection R. Now, P intersection R. P intersection R. P intersection R. P and R. Look at P and R. 32 is here also. 32, 33, 34, 35. This is P intersection R. Now, we see all three intersections together. P intersection Q intersection R. Now, what is common between all three sets? So, 32. 32 is here also, here also. 32, 33, 34 and 35. This is the intersection of P intersection Q intersection R. Common element between all the three sets. This is P intersection Q is the common elements of set P and Q. Q intersection R means it is common elements in set Q and R. P intersection R is the common elements of set P and R. And P intersection Q intersection R is containing elements common, that is common elements of all the three sets. Now let us draw for example 2 the Venn diagram. We have got three sets here. So we will draw the 3 circles in this way. This is set P, this is set Q, and this is set R. So, first this part is showing P intersection Q. This part is showing P intersection Q. Now, P intersection Q, what are the common elements? 27. First of all, when we have 3 sets altogether, then the Venn diagram, in the Venn diagram, you should write the elements which is containing common in all the sets, all the 3 sets, that is P intersection Q intersection R. So this is the part where it is showing intersection of P, intersection of Q and intersection of R also. This particular circle is showing, this particular part is showing P intersection Q intersection R. So we will have the elements here 32, 33, 34, 35. Yes, now P intersection Q. Look at P intersection Q. Already we have in this part 32, 33, 34, 35 already written. So only we have to write 27 to 31 in this part. So 27, 28, 29, 30, 31. So this full part is now showing the P intersection Q. Now come to this part. It is P in Q intersection R. This part is showing Q intersection R. So Q intersection R. Look at Q intersection R. It starts from 32 to 40. But 32 to 35 is already there. So we'll start from 36 to 40. So it is 36, 37, 38, 39, 40. Now we have Q intersection R. This full part is Q intersection R containing elements 32 to 40. Only this mid particular part is P intersection Q intersection R. Now come to P intersection R. P intersection R. This part is showing, this full part is showing P intersection R. P intersection R. So, P intersection R, we have got elements from 32 to 35. So, 32 to 35, 32, 33, 34, 35 already written. Therefore, here this part is empty. It will be empty. But this full part is showing P intersection R. Now, come to set P. This first circle is showing set P. We have got elements from 21 to 35. 21. From 27 to 35 we have in this intersection part. But 21 to 26 it's not there. So we have to write here 21, 22, 23, 24, 25, 26. So this now the set P is completed in the Venn diagram. In the same manner, we have to complete set Q. So, what are the elements of set Q? It is having the elements as 27, 28, 29. See, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37 up to 40. All the elements is there in set Q. So set Q is completed. Here nothing is remaining. Then come to this set R. Set R is containing 32 to 45. 32 to 40 is here. So 41, 42, 43, 44, 45. Now set R is also completed. So you can see that set P is full complete here. Set Q is also completed and set R is also completed, showing P intersection Q this part. This mid part is showing P intersection Q intersection R. This part is showing, this full part is showing Q intersection R, and this full intersection part is showing P intersection R. So this is the Venn diagram for 3 sets. Now let us take another example for intersection, learning intersection of 2 sets. Now see, this set A is containing the elements 51 to 60. Set B is containing the elements 56 to 60. So all the elements of set B is present in set A. Therefore, we can say that B is subset of set A. When we have in this way subsets, then what is the intersection? A intersection B is equal to as common elements here 56, 57, 58, 59, 60. These are the common elements of set A and B. So, when if B is subset of A, then you can see that A intersection B is equal to set B itself. If B is subset of A, then A intersection B is equal to set B. In the same manner, if another set is there, if C is subset of A, then A intersection C will be equal to set C. So, the Venn diagram, what is the Venn diagram for this? B is subset of A. So, Venn diagram we can draw like this way. Because all the elements of set B is present in set A. So, it is in set A itself. So, set B contains, that is A intersection B is equal to set B. So, this part is showing A intersection B. So, A intersection B contains 56, 57, 58, 59, 60. Now, set A contains has elements 51 to 60. 56 to 60 is already here. So, 51, 52, 53, 54, 55. So, this set A is now, it is fully complete set. This is the Venn diagram for subset. Now let us learn properties of intersection of sets. There are 7 properties. I'll explain with the examples, then you'll better understand it. Now, A intersection B is equal to B intersection A. So, if I take an example, set A as set B is equal to as suppose 3, 4, 6, 7. So let us find out A intersection B. What is common between A and B? That is 3, 4, 5. 3, 4, 5. Then what is common? That is B intersection A. Common between B and A. B and A you see 3, 4, 5. 3, 4, 5. These are the elements common in B intersection A. So A intersection B and B intersection A. You see the elements are the same here. So therefore we can say, so let us take this as point 1, this as point 2. So from 1 and 2, 1 and 2, we can say that A intersection B is equal to B intersection A. So this is one property, first property, that is always A intersection B is equal to B intersection A. In other way, if you take any other set, suppose set C and D if you take, then C intersection D will be equal to D intersection C. So any two sets, the relation, intersection relation in this way is the same. That is A intersection B is equal to B intersection A. Now come to the second property. If A is subset of B, then A is subset of B means all the elements of set A is present in set B. Then we can say that then always it is A intersection B is equal to set A. Example. With example, let us see. A is subset of B. That means all the elements of A must be present in B. A is containing suppose 10, 11, 12, 13. This is set A. Then set B is equal to as up to 15 suppose. Now, all the elements of set A, 10, 11, 12, 13, 10, 11, 12, 13, all these elements are present in set B. So, A is subset of B. A is subset of B. Now, let us find out what is A intersection B. A intersection B is equal to what? Common between A and B. So, it is 10, 11, 12, 30. A intersection B. Common elements between set A and set B. Now you can observe that set A element containing the elements as 10, 11, 12, 30. Even A intersection B is also having the elements as 10, 11, 12, 30. So we can say, therefore we can say that A intersection, if B, A is subset of B, then A intersection B is equal to set A. That is, if A is subset of B. Okay, this is second property. Come to third property. If A intersection B is equal to set B, then B is subset of A. Already you have learnt in the example before. A intersection B is equal to set B. Then B is the subset of A. So if I take an example, suppose set A as up to 60, then set B is equal to as 658, 60. This is set B. Now, A intersection B. Let us find out the A intersection B. What is common between A and B? 52, 54, 56, 58 and 60. 52, 54, 56, 58, 60. This is A intersection B. Now, A intersection B is equal to set B. A intersection B is equal to set B. You can see that the elements in set B and A intersection B is the same. So therefore that means B is subset of A. So if A intersection B is equal to set B, then B is subset of A. If it is like this way, if it is given that B intersection A is equal to set B, if it is A intersection B is equal to set A, then A is subset of B. Now fourth property, A intersection B is subset of A and A intersection B is subset of B. A intersection B is always subset of A. Let us take two sets. Set A as set B as now. What is A intersection B? A intersection B is containing the elements as 5, 6, 7, 8, 9, 10. You can see this set A intersection B, 5, 6, 7, 8, 9, 10. All these elements is present in set A. So therefore we can say A intersection B is subset of A. And again A intersection B, all these elements is also present in set B. So this A intersection B is also subset of set B. So this is one property. Next, fifth property. A intersection complement of A is always equal to a null set. How? When we talk about complement, then the universal set comes first. Example, you have to take an universal set. Suppose if I take universal set as numbers 1, 2, 3, 4 and so on up to 20. Then set A, I take it as suppose 1, 2, 3, 4 up to suppose 12. This is set A. Now what is complement of A? You have already learned complement of A. Complement of A is you leave out these elements of set A, the extra elements, that is the elements which is not present in set A, but it is present in the universal set. So, numbers from 1 to 12 is present in set A, but after 12 it is not present in set A, but it is present in set universal set. So, that becomes the complement of set A. So, after 12, that is 13, 14, 15, 16, 17, 18, 19, 20. This is complement of A. Now, I have set A and I have complement of set A. So, I will find out the intersection of these two sets. That is A intersection complement of A. So, A intersection complement of A, what are the common elements here? You can see that there is no common elements at all. So, it is an empty set. Therefore, we can say A intersection complement of A is equal to a null set. In the same manner, B intersection complement of V will be equal to a null set. C intersection complement of C is equal to a null set. So always a set intersection its complement is always equal to a null set. Now let us come to property 6. A intersection A. A intersection A. Intersection between the same set is equal to set A. I will take example. Suppose set A is having elements as 1, 2, 3, 4, 5, 6, 7. Intersection. The same means I have to take intersection again set A only as the same element. 1, 2, 3, 4, 5, 6, 7. Same element. Set A. So, A intersection itself is equal to set A. So, A intersection A is equal to the same element 1, 2, 3, 4, 5, 6, 7. Therefore, we can say A intersection A is equal to set A. B intersection B is equal to set B. C intersection C is equal to set C. D intersection D is equal to set D. The last property, A intersection a null set. So, I'll take, suppose set A is equal to as 11, 12, 13. This is set A. Now, another set, suppose if I take set B, it is a null set. Now, what are the common elements between them? That is A intersection B. Nothing is common because here B is not having any elements. It is an empty set. So, therefore, as B is an empty set, I can write it as A intersection an empty set is equal to as an empty set. A intersection B and A intersection empty set is equal to as an empty set. B intersection empty set is equal to empty set. C intersection empty set is equal to as a empty set. So these are the properties of intersection of sets.